Assalamu alaikum, welcome back to my channel. Last time we learned how to make DB schedule. I hope you remember, and if you are new to this video, please check my previous video. So we was creating one DB schedule only for this villa. So anyhow, this one we don't have to create for all because this one is typical to all. So I have did some changes here to balance the DB. So you can follow same to this all. So today I am going to teach you how to make single line diagram. So single line diagram meaning normally we make for SMDB, submain distribution board. So the submain distribution board same like DB schedule. So if you see in the DB schedule, you will see amperage and then the connected load and then the cables, amperage in breaker and connected load and the wires, and what is the load also. So here it will be same, you will see the breaker and then the cable size and also connected load. It's nothing different, but for the DB it will be a DB schedule, for the SMDB it will be a single line diagram. So normally we call SLD. So let's see the DB first. So this is the DB schedule what we made last time, and I hope you remember this electrical wiring code. You have to download from the internet to learn more things. So let's open the DB schedule first. Open. So here you will see this breaker triggering milliampere load, and this is the circuiting, and this is the breaker size, and this is the wire, and this is where is loading, and this is the load, and here demanded load. This is DB schedule. So in the SLD diagram same. So I will draw something, the basic thing, so you will understand. So let's put one line here. So I will use polyline. Okay. And another line here. Let's draw up here. So normally there is many way to draw the breakers, and if you go to the Kahrama book which I show you before, in this book, and you will I show you in the last video the symbol what we are generally used. Let it open. So here normally we use something like this, one circle and one arc, a enter arc. So it will be something. Let's open this, and we will repeat this. Copy. Let's straight. So let's trim this one. TR. Click. Click. Then it will continue something like this. So here we will put the breaker size. Actually this is small. Let's make little bigger. Okay. TR, click, click, enter. Let's stretch this one little bit up. Okay. So here we will copy one of text here. So copy. So let's take it here. So I will make it this one little bigger. So let's say this one 200 ampere. 200 ampere, and another copy. MCCB, lock MCCB. This is molded case circuit breaker. If you use a different kind of circuit breaker, you can put it. So this is the main incomer. This is the very basic SLD, how to make very basic SLD, not advanced. So we will make same here, copy, we will put it here, and this guy will come down. So here we can make it 80. So this DB schedule, I hope I put it 80. So let's keep 80 also here, or you can go for the if you want to go for the here 100, sorry, if you want to go for the 80, you can make it this one 100. So what will happen, instead of overload, before the DB, SMDB will be off. So let's say if the overload came, it will be more heat and it will get fire. But if DB can handle 100 ampere, the fire will be happen, the fire accident will happen if the load reach more than 100 ampere. So before reaching the 100 ampere, SMDB is already 80, so it will trigger. So any fire problem happening in the house will be reduced. This is one of theory. So always general, some not always, some designer make in the reverse way, meaning the last circuit, if it is a lesser ampere, sorry, higher ampere, then the before one will be more. That meaning DB will be higher ampere, SMDB will be lower ampere. So you can ignore the accident, whatever going to happen into the DB, you can ignore that one. I hope you understand. Let's draw it something. Maybe you will understand more. So this is 80. Let's say this is 100. No, 60. So let's say 40. This is for example only, for understanding purpose. So this is all breaker are interconnected, something like this. Okay. So in case of fire, I am having 60 ampere load here, 60 ampere load, some overload, 60 ampere overload. I will type OL, O/L. Let's consider that is 60 ampere overload. So which one will be trigger first? This one. After that this. After that this. Actually this two will not trigger off, because when this one reach 60 ampere, this one will be trigger off, this one will be off first. So let's say this is house. Let's say this is a house. Let's say this is what we will say electrical room, ELRM, and this one let's say main electrical room. So when any power overload come, let's say 60 ampere is overload, so this will be trigger, this will be off. So maybe this one normally will be near to some security people, something like that. So maybe you are out of the house, some overload current came, so your house is safe, the electrical room safe, because the trigger happens in the main room, which is already with the security room. I mean already near to the security room. so no need to vary. So let's say this is opposite, so this is, let's say, 40 and this is 60 and 60 is same, let's say 80. If 60 ampere overload, security will not know, electrical room will be not off, house will be burned. So when the security room people who are in the security room, they will know your house is burned after seeing the fire. So this is not okay. So I will make undo. So prevent this kind of accident, some designers, okay, yeah, I have to redo. Some designer work like this. So if you see in your house, you will see dB is 100 ampere breaker inside the dB, but the government will give you 40 ampere. You will see it's not logic, because we have receiving 140 ampere power from the government, but our dB inside 100 ampere. Why? You may think this is the reason. So same way, so there I have 80, so I can go for this one 60, but I can keep 80 here, but here I have to go, let's change to 100 because it's better. So I have 33 ampere, actually 33, 34, thumb rule it can be 60 ampere load, so it's okay 100. So here I will go with the 80. I hope you understand. Then the dB symbol, REC, we will make the dB symbol like this, polyline H, okay, I will go to H, enter, pick point, okay. So this is the dB. Then I will go for the load, copy here. So what is the load? Connected load, let's make bigger, connected load 33.2. So I will put it here, C 33 point, I think 2 kW, I think 33.2, right? Yeah. Demanded load 19.08. So I will make this up and move CL, connected load, copy, demanded load DL. So how much demanded load? 19.08. 19 point, oh, already I have 0.08. So where is the location? It's very important. Another thing also important. Let's copy this one. DB name, I put it here. DBGF villa number 1. Copy. Okay. Now this one done. The next, we will copy this one. The cable, we will rotate this. If you don't understand 100%, no problem, but try to understand minimum 50%, because normally the draftman or the engineers, does no need to engineers not they don't have to draw this because it is already will come in the IFC drawing, the designer. You have to just update this one, but you should know how to read this one, otherwise you cannot work. So what kind of cable I put it in the DB? 4 core 35. Let's copy this one. So you will put it here. So let's make this one convert to text, txt to mtext. Okay, double click. Let's increase this one. Okay, so let's move this one down. Let's click this one. Yeah, perfect. Then I have here 18. Let's make this one down. There's another thing, voltage drop. So this one I already told you how to calculate, but for me I don't want to repeat it. But if you know max very well, I show the formula, just calculate it, the voltage drop, and remember this is should be percentage. So VLD VD, so I will put it here like 2.5. Let's go for the duplicate. Sorry, VD, yeah. Voltage drop. So this is the very important thing. So this in 200 ampere MCCB, actually this is MCB, main circuit breaker. This is not modded case. So actually what happened here, 200 I just put it, I didn't calculate it yet. So maybe this one can be increased. So how many will we have? So as we see here, we have 2, 4, 6, 8. So let's copy this one, copy, click, let's go for the array, type 10, no, let's go for the 12. So 6 left side, 6 right side. Okay, okay. So this one has to be up to here. And this one should be up to here. Okay. So what will happen? This 2 will be go, because we have only 80. This 2 will be go, no need. This one I will put for spare. Let's make this one spare. We will use one of this one. I forget to put the percentage. Sometime I forget something, but please try to connect with me when I am talking. Please listen, don't forward, because I tell to you by word, but when I am typing I forget. So this one should be percentage. So it should be correct at all. And my advice, when you are making a drawing, be a lazy to do hard work. So always try to find a easy work, easy to finish your work. Be a lazy to do your work hardly. So some people, they do work very hard, and don't be like that. Always try to find the easy way, so you can finish your work very fast, and at the same time you can gain knowledge while searching. So if you spend one day for searching, no problem, but you will finish the 10-day works within 5 days if you find the easy way. So be lazy to work hard and be smart and finish the work. So this is the basic thing how we are going to make the how we used to make the single line diagram. So if you print out this one, so they will know, okay, this villa number 1 2 I didn't rename, you have to rename this one 1 2 3 4 5 6 7 8. Okay, this is the load and this is the cable, this is the load, this is the cable. And as I told you before, as per the voltage drop, cable size can be changed, and I also teached you already how to change the cable sizes. You will check the voltage drop. If it is coming more than 2.5, you will change. Maybe you will go here for core 50, and this one will be 1 core 25. So my previous video, please, if you don't understand what I am telling here, please check my previous video, because very important thing I have already teach there. If I repeat it again here, it will be take too much time. So another and again I am simple explanation. So this is the DB name, this connected load, demanded load, voltage drop. You can check the Kahrama book, how much the maximum. I think it's already open. Let it be open. Okay, this one. Okay, it's very slow. Okay, this is the symbol what I told you. You can check the symbol. See this miniature circuit breaker MCB, MCCB. This is the breaker what I told you before. And if you come down, okay, here it is. The voltage drop here up to 4, meaning up to socket. So let's consider this one 2.5%. Please, you have to reach 2.5. This is as per Qatar standard. If you work in different country, you have to follow that country code. So this is that one, and this is the cable. You have to increase the cable as per the voltage drop. So I forgot to put another one, and there will be another one here, distance. So you have to mention the distance here. So this distance, so when this consultant, he will check the load, connected load, and he will check the cable, he will check the distance. So he will calculate is this voltage drop is correct or wrong. Maybe some people they put just imaginary voltage drop and they submit to get the approval. So consultant will check this one. So this is the breaker, and you know this is not, it will not be a whole cable for core 35 as per the distance, it will change. So this one I calculate for core 35, so this one it will be for core 25 maybe as per the SMDB location. So this one we don't have to care about it because this is only for the service cabinet, so we don't have to put it in the single line diagram. So there's one of my subscriber, he was asking where I can find the spare. Actually spare is space with the breaker. Actually spare is it will be only the breaker, there will be no cable, nothing. So here let's say the owner of this area, he wants to build another house here. So he want to connect to the, he need electricity. So he want to connect to this particular SMDB, sub-main vestibule board. Let's say there is no spare. Where he will connect? There is no place. Either they have to distribute from here, you have to put another breaker or SMDB here, then divided the SMDB 2 and another 2 dB and 1 dB for the old and 1 dB for the new. So this one will be changed. Too many issues. Because why? If you don't provide it a spare, you don't have a space. And later also you cannot add the breaker, because when you give to this line, single line diagram will be go to the manufacturer. So he will create the SMDB panel he manufacture as per this one. As per this one he will manufacture the SMDB size. So later you cannot add. So the future use they add to spare. So when they to spare, sometime there is a space also we add. Let's add some space also. So you will learn what is space also. So this is no more. EX, click, space. Okay, I will teach you what space. Okay, if you put it this one, he will make the he will manufacture the SND as per as per this one, and he will include this spare breakers in the space also. So the panel will be bigger. So if you make any new house here, you will connect that dB, particular dB, to the spare. You don't have to buy a breaker, because the breaker already will be in the panel if it is spare. So when the manufacturer making cost making for the panel, he will include this spare breaker also, so you don't have to buy the breaker. But the space, he will keep just empty space. So if you need another breaker, you will buy your own money breaker and you can fix and you can use. This is why they use space. So I hope you understand the single line diagram. So what will happen, actually this is the very basic. Normally we have all the electrical people have some templates. So this template something will be look like this. Something look like this. I cannot share this file because this is our company file. So here I copy something for understanding purpose. Actually this is MCCB also. Let's put MCCB. Where is our, yeah. This is also MCCB. Let's select this. This is my mistake. Right click, find MCB. Let's make MCCB. Replace all. Sometime I forget also. But always even I forget, it will be fixed automatically when I am teaching something. If won't fix, I will put another video or I will correct it in the comments. So read the comments also. Don't forget to read the comments. So something like this. This is the base template. So you will see this RYB is indicator, red, yellow, blue, circuiting, and this is meter. You will see, Google it, SMDB, sub main distribution board, you will understand. And this is the amperage, and this is the triggering braking amperage, and this is TP meaning triple pole, MCCB means main circuit voltage gate circuit breaker. And here you see, here I will teach you only the main thing. The rest thing is a specialized design. You don't have to learn that one, but when you are working you will learn. Also some item, it's also new for me. See, 400F, I don't know this one also, because this is new for me. Some people, if you don't know this one something, you have to go for the legend, because the designers, they put too many things. So I think There will be somewhere. I don't want to show this file too much. And this is the breaker. So here they draw different type of breakers. So Q1, Q2, Q3, same like R1, Y1, B1, something like that. So here you will see 63 ampere. For now this one, forget about it. 63 ampere 3 phase, 100 ampere 3 phase, 40 ampere 3 phase. This is breaker size. And this is ST, meaning sand trap. Check in the Google what is sand trap. No need to complicate it everything, just focus on what I am telling you now. And this is located the buildings, and this is total connected load, maximum demanded load, and then incoming from where, and this is the dB name, and this is how many way. So this is normally like this, but if you go here, it's very simple. Just put REC. Let's make little down. So let's name this dB. Copy. Let's name SMDB dash 01. Then we will copy this one. Location. It's not necessary it should be same what I show you. You can make like this also. Let's put security row. And connected load, you can put it here also. Total TCL, total connected load, how much will be? So 33.2 into 8. Let's calculate. Yes, here 32 into 2 multiple, let's multiple into 8. So 257.6. Two 5.7.6 kilowatts. Then TDL, total demanded load, how much? 19.08 into 8. So it will be 152.64. As a thumb rule, we will go here. We have 250, so we will go here 600. So I will consider 300. So double 600. No need to go for the thumb rule. 20, let's say 260. 260. As we calculate before, 1.54. We can go for the 500 ampere breaker. I think available in the market 500 ampere. Okay, so 500 ampere breaker here. Let's calculate incoming cable for the 500 ampere breaker. So same schedule. here. Okay, here. So current rating cable right directly in the ground. So we cannot go. So let's go for the 250. Meaning 2 number, we can go 2 number 240. Yes. So we can go here, copy. Two by 4 core 240. We need to run, and 1 core by 120, half of the no 240 also, because we have 2 run 240. So why this is big cable? Because we have 257.6 kilowatts, because this is higher volt. So like this we have to do. So normally we don't put all this dB in the 1 SMDB. So what we normally do, we put 1 SMDB for here, 1 SMDB for here. So what will happen, the main incomer breaker will be reduced, the cable will be reduced, everything will be reduced. So it will be divided into 2. So this is the main thing. If you go here, here, and this is the same thing here will happen. So you here total connected load, maximum demanded load. This is the cable for run, and this is coming from where? Actually this is we are tell 2. This is now this one is 14 way. So here I have how many ways? 8, 10, 12. So this is 12 way. So here I will put 12 way. 12. So let's put 12 ways. So why I am not showing everything here? If I show here everything, is already template is ready, so you will not learn anything. So here I put everything, so you will learn everything for the learning purpose. So this is the important thing. The important thing all I put, and here another one I forget put TPN. So TPN means this breaker will be switch off 3 phase, meaning RYB, and the same time neutral. If it is TP only, that meaning it will not trigger the neutral. So there is a different kind of breakers available in the market. It will be changed as per what you designer request. So we will put the breaker here. Let's put more breaker. So space, no breaker. So this is the main important thing I already covered. But if I divide this one into 2, let's make 2 some dB. So I can put 4 in 1. 2, 4, 8. Actually here I have 10. 2, 4, 6, 8, 10. This is wrong. Let's reduce this to. If I want to divide into 2, you can put 4 in 1 SMDB, this 4 1 SMDB, and the same time you will provide spare, and this all will be reduced, and the cable reduced, everything will be reduced. It depends. Normally we don't put all in 1 SMDB. So here if I go to the template, this is general template. So the location, everything I already mentioned. So I will give you this one, only this one. No problem with this name. MSB, MDB, nothing different. Main subboard. I think this one, but normally we call main service board. I think MSB. So we call MDB, main distribution board. So this SMDB always feed with the MDB. Now I am teaching you only the SMDB. Before I teach DB, now I am teaching SMDB. Then I will go for the MDB. So don't worry about this thing now. This one, don't worry. This one I already teach you the cable, and this length in the meter, this is 320 meter length, and voltage drop you know how to calculate. Same what I told you before. And this one you can put it here also. You are not put, no problem, it is already here. So this one you can put 5 ampere, either put or not. This is all this whatever I didn't mention you, it's not important. What is important I already mentioned here. Okay, the rest is general. Mostly it will come in the every SMDB. You keep this template, and in future you can use same. This all I removed. There is something I have to teach you more, like ATS panel and the UPS panel and too many things. I will teach you that one later, but I don't want to confuse you everything for now. So this is edit and a special design. This one I will remove also, no need now. I will give you this file, and just keep it. This will modify as we want. This one you know already, 415 volt is incoming voltage, 3 phase. This one breaking level, I think. Actually this one no need, 4 watts. Actually this is 4-way, I think, meaning red, yellow, blue, neutral. I think this is the 4W meaning. So some, if as a designer mention special text, they will make in the legend, so always check the legend. So this one no need for now. 50 hertz, you know, this is if you are good in electrical, you will see more of the electrical equipment, 65 hertz, 70 hertz. There's too many things. Most the wavelength, this is per second, and this is rating 25 kA for 3 seconds. Check in this one also Google, but normally we don't put. This is the first SMD way I am saying this too much detail, but it is not necessary. So this is instead of Q1, Q2, Q3, you can go R1, Y1, B1. This is what is regularly we use. This SMDB I copied from the different kind of project, and actually this is a specialized building. So we will go with the general. We don't need to learn the specialized, because specialized, when you go to that project you will understand. So every project is different. So I will go with the general, because if I go to the specialized, I cannot teach you specialized, because every project different ideas. This one Y1, you can go for the B1. So this is same will be continue, R2, Y2, B2. So I will keep the important thing, the rest I will delete. So you may ask why you didn't delete before I am making the video, because I want you to know when you go to any project you will see this type of issues. Even I have 15 years experience. Some SMDB when I am seeing I don't understand also. So what I do, I go for the legends. So you can complete R3, Y3, B3. So this also you can check. This is a important thing. This one I will tell you what is the important thing. The first thing this, the second thing this, and the third thing this one, and the fourth here, actually here, and the fifth the incoming cable. This is the very important. The rest even you have or not have, not a issue. This everything very important, the cable everything important. So let me copy this one from my this video, this one I will copy this total. Because this one I am going to repeat. So let's come here. Okay, smaller. Okay, this one I don't need it anymore. Okay, this one also I don't need it. Let's delete all. So this one and this one I need. Move. So another thing, when you do some work, just make look nice. So this is little look nice, colorful. So this one will be written copy. So 2, 3, 4, 5, 6, 7, 8. The rest one you can make space anywhere thing. So let's keep this one 14 as it is. Then the MSPB 08 will be, what name we put? SMDB01. So let's go SMDB-01. SMDB-01. And this one we don't know yet, so let's keep empty, because still we are calculating. And this one, it's a 2 run. And this one is a 120. And let's keep the voltage drop, and then the length something same. Let it be same, because that one as per the calculation will be changed. This one I will put it here. Oh, let's BU RST burst. Let's put it here. And this load, this one located in security room. Let's put located in main building. Let's put main building. Please check my please continuously check, don't ignore, because sometimes I tell you very important thing between this. So this all done. So let's go for the spare space. I have one here where I put, okay, this is spare, Control Shift C. Let's put spare. For spare, the rest will be space. Space. Let's copy this one also. It's a big SMDB will be here. So if it is a space, I don't need this one. And let's connect these people here. Okay, now connected load. Let's copy this guy there. Control Shift C. Oh, here. Control V. Oh, it's very big. Let's make Control Z. Control Shift V. So it will paste as a block. So SC, enter, click 1/50. Okay, it's good. X enter, break. Let's go for the connected load. So I will put it here, connected load. Oh. And demanded load. Let's copy. Demanded load. Okay. Now this one we can go for the R1. So in the MDB also will be there. This is not okay. Okay, let's make this one red color. So this is how we do SMDB diagram. So I remove which is not necessary, meaning which is for the advanced design. If there is an advanced design, you can go with the, you can check with the legend. So let's talk about the advanced design. What is advanced design? Let's say I have a building and there is remotely I want to operate the power controller. So there is one specialized breaker with a data connection, and you can switch off the breaker from internet. This is specialized. And future maybe it will come, maybe I already available, I don't know, maybe available. You can switch off your breaker from the mobile. This is advanced. So for now my purpose to teach you the base. If you know the base, it will be no difficult to understand the advanced. If I teach you the advanced now, then if I come another future, another different kind of advanced technology, you have to learn again, because you don't know the base. So my purpose to make you understand the base. So when the advanced come, you will understand very quickly. So I don't want to waste my time to teach the advanced things, because every time it's changed. So understand the base, learn the base, and the advanced thing you will learn after. So you see I delete something, I will go for the drawing. See here, this is 320 80 test TP 400 AF. This one all advanced breaker. And if you see this ST strain trip, this is also advanced. And if you see some technical notes here, something which is not very basic, and these are the things I will teach you later. You will see this is here UPS, and this is control panel. These things I will go for you later. If I put everything one time in your mind, your brain will be blast. Then I will be the killer. I don't want to kill your brain. So this one very important, very important. Understand this maximum, then you can go for the next thing. What is this? The code. Okay, I hope you understand. If you don't understand, repeat it and check my video again and again until you understand. And you Google it, If you want, if you have advanced mind and the something what I show you here, you want to know, if you are eager to know, check in the Google, no problem. But I am targeting the base thing, so you will understand more because I learn from here, and I am considering you same as like me. If you are advanced, you can go for more thing. So let's again, we will go start. DB name, connected load, demand load, voltage drop. You know how to calculate this one, and the cable, and what is the breaker should be here. And I told you in the DB breaker and this breaker, what is the difference? This is 63 ampere, but we didn't put here 63 ampere, I think 80. But in our DB we put 100, so you will go everything here up to here. 100, no 80, because there is 100. So it's a TP. I will go for the TPN, and let's delete this SLD. Little boring, not interesting, but what to do? If you want to be a professional, you have to learn these things. So let's copy this one. I should go for the copy area. Okay, let's keep the spare breaker like this, no problem. And this is not necessary only 3 phase can be connected. You can connect also single phase, no issues. For the more information, okay, so check this one, learn very well. If you don't, if you have any comments, please put it in the comments. As soon as possible I will reply to you, and take care. We will meet in next video. Bye. Assalamu alaikum.